All right, so today we're going to be going over DMS, but before we go over DMS, I just want to talk a little bit about static and dynamic types. So what are static and dynamic types? So for when we have some sort of object reference variable foo, its static type is going to relate to what we declare its type to. This is the type that the compiler sees. But when we actually run our code, we will see its dynamic type. Its dynamic type relates to the instantiation of the variable foo, right? It's what foo will actually be during runtime. Then we have class A and class B that extends A on the right-hand side. With that said, let's go ahead and look at what different types of instantiations and declarations we can do and which ones are valid and which ones are invalid. So let's go ahead and look at bar and biz. For bar, we declare its static type as A and its dynamic type as B. Does this relationship work? Well, in order to determine this, we're going to be using the is-A relationship. This goes from right to left, or its dynamic type to its static type. We're going to ask, is B an A? B extends A, right, in the class. Therefore, all B's are A's, so this works. But what about biz? What do we know about the relationship between A and B in the opposite direction? Are all A's B's? Well, not necessarily, right? All we know is that the class B extends A. We don't know that all A's will be B's. So this does not work. This will result in a compiler error. If this is a little bit unintuitive, let me give you maybe a nicer one. We have class A as person and we have class B as student. Can we say that a person A will be set to a new student? Does this relationship work? Are all students people? Is a student a person? Yes, so this works. But what about the inverse? Where we say student B is going to be set to a new person. Is a person a student? Not necessarily, right? Not all people are students. So this relationship does not work. So what I want you to take out of this section is that the static type relates to the type declaration. That's what we see during compile time. And during runtime, we see its dynamic type, or what we instantiate the object to. Now let's get into dynamic method selection. What is dynamic method selection? Dynamic method selection is essentially a way for us to determine which method we're going to run when we have a lot of methods with the same name and maybe differing parameters. So we're going to often see it with this sort of structure, right? Where we say the instance and we're going to call a method through our dot notation and pass in something for the parameter. An instance is just this line, what we see over here, right? When we declare a reference variable and assign it to a new instance of A, and then we can call it, call a method using the dot notation. So we're going to split this up into two sections, compile time and then runtime. So let's talk about what happens during compile time. So during compile time, we're just trying to find the method signature that we'll be using during runtime. Method signature just specifies which parameter type we're going to be taking in. So first, we're going to collect all the methods with the same name, starting from the static class and going up the class hierarchy until we hit the root. We're going to exclude those that overwrite or those with the same parameter type. So same exact method signature, we're going to ignore those. And we're just going to keep the one that we find during the static class. So if that's a little bit confusing, at least that first step, that's all right. I'm just going to go ahead and copy this And let's go over an example. So first, we must collect all the methods with the same name, starting from the static class and going up the class hierarchy. So we notice that we have bar, which is of type C, static type C, and we're gonna say bar.f new C. Oop, did not mean to erase that. Bar.f of new C, right? We're going to be passing in a C. Now, the important thing is that we choose parameters that are related to the type C, right? We choose methods that have the parameters that relate to the type C. So we're starting at the very static class, which is going to be C. We're going to look for the method f, and we have f of a. Is a, the parameter that's passed in, related to C, which is the argument that we're given? It is, right? A is a superclass of C, so we're going to collect it. Now let's go ahead and go up the class hierarchy at class B, which class B extends A and class C extends B, right? These are all related. So we're going to be looking at this method right here. Does this method f of B relate to C in any way? Well, B is the direct parent of C, so it does. We'll collect it. Now we're going to go up the class hierarchy once more and look at f of A. Now this is interesting. We've already seen an f of A in the static type of where we started, right? The static type C. So this is an override of the method that we've already seen. So there's no need to select it. Java will prioritize the one closer to the static type, which is C. So we'll prioritize the f of A and C. Now that we've collected all the methods with the same name and some sort of parameter relating to the argument passed in, that's a very important part. Please don't forget that. Let me maybe make a note of that. So we select methods that have a relating parameter. And what I mean by relating parameter, maybe that's not the best word choice, but let me explain, right? The parameter that we pass in here is going to be C, and C is related to both B and A, which are the types that are passed into the methods that we were looking at, right? If it takes in some arbitrary f of z, we don't really care about that method, right? Because it's not related to C. With that cleared up, let's go ahead and go over the next step, which is find the method with the most specific parameter type to the argument passed in. The passed in argument is going to be C. But what about the methods that we currently have? None of them directly match C. So what we have to do is find the closest parent to C. We notice that C extends B and B extends A. So between B and A, which class is closer to C? Well, B is a direct parent of C. So we're going to go ahead and select this method, right? B is closer to this C. Now we're going to lock this in, right? We found a method signature that works. But what if we didn't find a method signature that works? What would that look like? So let's say instead of C, we had some arbitrary class that's unrelated, Z. Would any of this work, right? Well, when we collect all methods in the very first step, we have to make sure that we collect methods with parameters that relate to what we're passing in. Does A, B, C, whatever, do these relate to Z? No, They don't, right? So we'll have a compiler error because no method takes in anything related to Z. Great. So let's go back to the example that we were discussing, the lovely C. Great. Oopsie. Now we need to lock this in. What does locking in mean? Locking in, just think of it as remembering it for runtime, right? We're going to be saving this method signature. What does that mean? Method signature just means, again, the type of the parameters that are taking in. So we're going to be taking in a method during runtime. It has to match f of b, right? What we have saved, what's highlighted right now. Let's lock that in. Now let's move on to runtime, right? And in runtime, we're asking, can we do better? Can we find a more specific f of b according to the dynamic type of the method we're calling it from? And how do we do that? Well, we have a whole bunch of steps. Again, let's just copy this and make it a little bit smaller. But we're going to look in the class corresponding to the dynamic type for the identical signature locked in on during compile time. If the signature exists, then we're going to use that one. But if not, you're going to continue up the class hierarchy, just like we did earlier, to see if any other identical signatures exist. And we want to find the closest one to the dynamic type. Again, we locked in what's highlighted, f of b, and now we're going to look in the class corresponding to the dynamic type of bar. The dynamic type is going to be the same thing. It's going to be C. So we're going to look in C, the class C. Does the class C have a method that takes in f of b? No, right? We locked in the method signature f of b, and we have to find that identical signature according to the dynamic type of bar. But it's not there, right? So we're going to jump into this otherwise case, where we're going to check the superclass of C, which is going to be B, and hey, would you look at that? It's just going to be the same exact method that we locked in on during compile time. And so when we actually run our code, we will be running this method right here. It's going to be the same one that happens during compile time. Hopefully that wasn't too bad. Let's go over an example where we'll see that the runtime actually affects what method we're going to be calling. Let's restart. And now I want you guys to be paying attention to these two lines over here. So we're going to create a new foo with its static type C, and its dynamic type is going to be D. Does this work? First of all, is what we should ask. Are all D's C's? Well, D extends C, so yes, we're fine there. Great. Let's proceed on to compile time. In compile time, again, we're going to analyze the method call. We're calling foo, which compile time, its static type is going to be C, and we're passing in a new C. This is the same case that we saw earlier, right? Bar was of type C, and we're passing in the new C. So we should be locking in the same method. Let's go ahead and breeze through the compile time just once more. It should be the same exact thing as what we did earlier. So what we start with, let's go ahead and refresh ourselves. We're going to collect all the methods that have a relating parameter with the same name, starting from the static class and going up the hierarchy. All right, so we're going to be passing in C, and we're going to be starting at class C. So we have this method, right? A is relating to C, so that's fine, right? We'll go ahead and collect this. Then we're going to go up the class hierarchy of the invoking method, right? It's foo is invoking the method call. And we are going to collect this, right? CB relates to C, so this parameter type works. And class A is that f of A, right? We've already seen it, it overwrites it, so we don't really need it. Now we're going to choose of all the ones that we've highlighted or all the ones that we've collected. We're going to choose the one with the parameter that's closest to C or most specific to C. And in this case, that's f of B, right? B is closer related to C than A is related to C. So we're going to lock in this method right here. Same thing that we did last time. Nothing has changed. Once we've locked that in, what happens during runtime? Well, foo's dynamic type is going to be D. So we're going to look in the class corresponding to the dynamic type, which is class D. And we're going to look for the identical signature that we locked in on during compile time. So let's go ahead and look at class D. We have two methods. We have f of B and f of C. Notice that we're passing in a C in our method call. So, hey, the most specific one, oops, didn't mean to erase that. The most specific one is going to be this. Shouldn't we select f of C? Not necessarily, right? The rules dictate that we have to go with the identical signature that we locked in on during compile time. And again, we locked in the method signature F that takes in a B. So we're going to go ahead and run this method, right? We have found a method that is better. It's more specific to the dynamic type of foo, right? This, you can think of it as being outdated, right? This relates to the static type of foo. So we're going to go ahead and find our new method, and we have finished our dynamic method selection. This is what a different case happens when we have a dynamic type, and we can do better. Great. So that was a brief overview of DMS. Let's go over and jump into casting. Great. So let's go over casting. What does casting mean? Well, when we cast in Java, all it necessarily says is it tells the compiler, hey, I'm going to change the static type to, well, whatever we want it to be casted to. So in this case, we're casting the instance invoking the method call, right? Foo is the instance and it's calling F. That's what invoking means. Oh, that's not a highlighter. And this is what casting looks like, right? We're saying, hey, foo is going to be of type D when we actually run the code, right? So let's go ahead and apply this example over here. So let's say we have this code, right? We're essentially telling the compiler that the dynamic type of foo will be D during runtime. So we can say, treat foo as of type D, because we know during runtime it'll be of type D. Let's see how that changes our code, or our DMS rather. So again, we start with compile time. We're going to find the method signature. How do we do that? Well, we're going to look in the static type of our calling function, which is going to be D. And we're going to look, hey, do we have a method F that takes in some sort of relation to C? So let's go ahead and look in class D. We have F of C, right? As C and C are going to be the same class, so this works. Let's collect it. Oops. Now let's go ahead and collect the next one, right? This is still a method that's different than the last, and B is still related to C, right? B is the direct parent of C, so this does work. Now let's move up the class hierarchy. we're going to move up to C, and we're going to look at the method there, right? We have f of a. Again, f of a is related to C still, right? It's just two parents above. So let's go ahead and collect it. And as we move up the rest of the class hierarchy, we've already seen this method signature, right? We've already seen f of b and we've already seen f of a. So we can ignore these two. Great. So we've collected all our methods. Now, again, compile time says we have to choose the most specific method. And what does that mean? The most specific method with the parameter closest to the argument we pass in. The argument is C. So between the classes A, B, and C, which is the closest to C, hopefully this is obvious, right? C is going to be the same as C. So we're going to go ahead and lock in this method signature. Let's go ahead and erase the rest of them. Now, during runtime, the dynamic type doesn't change, right? Foo's static type was D, and during dynamic type, it's still going to be D. So when we jump into the runtime portion of DMS, nothing really changes, right? We look in the dynamic type, which is going to still be D, and do we look, can we find the same method signature that we locked in on during compile time? Yes, in fact, it's the same exact method. So we're going to go ahead and take this method and we're done with our DMS. This is the method we're going to be calling and casting. And yeah, that was DMS, that was casting and static and dynamic types. I hope that was helpful. Yeah.